Hello, this is TelecomTV. I'm Martin Warwick. We're here in San Francisco in California at the DPDK Summit 2014, and DPDK stands for Data Plane Development Kit. I'm talking with Andras Kovac, who is a lead software developer at Ericsson. Andras, welcome. Let me begin by asking you this. Why is DPDK so important? And why has it come to the fore right now?
It is because packet processing before was on specific ASICs, dedicated packet processing chips. And as Intel tries to come into the packet processing business and area, they have pretty powerful CPUs. But the problem with that, they not really match at the very moment with the packet processing requirements. And the DPDK gives a pretty good tool set to the developers to use the chip itself very efficiently.
So DPDK is new?
It is. In terms of the availability and its, the feature set it provides. So the latest one came in July. Probably DPDK 1.7, that is really pretty much similar to the packet processing engines. So now it has really a wide variety of possibilities. We can really use it on x86 really well. The earlier revisions just showed the way what is it gonna be or how to use x86 pretty much efficiently, but it really needed too much additional coding. But right now it is pretty mature.
Thank you. Now, a lot of DPDK is based around the notion of the library. Now, we all know what a physical library is. There are shelves with books on them. How important is the DPDK library, and what is actually on the virtual shelves?
In the Linux environment, usually the coders are always lazy. So we just like to use pre-written libraries, pre-written codes. We just copy paste. But DPDK itself provides something we have not had before, and it also shows the way how to efficiently use the chip. And the figures with DPDK are really much better than without DPDK itself. So if I am performance aware, really, this is a great choice to use DPDK to be fast and efficient.
So Andras, what about practical implementation as far as DPDK is concerned? What are the models? How easy is it to use? And what are the challenges?
Basically, there are two models we used to use. One is the run to completion model, where we have a single process and it does everything with the packet, and when it's done, just sends it. The other model is basically the pipeline model. DPDK introduced this packet framework in 1.7 revision again, and this really much supports this pipeline model. The challenge is to decide which one to use and to code it the most efficient way possible, because both solutions have, of course, advantages and disadvantages, and it is only our decision which one to use. Because, for instance, in case of a pipeline model, we can have different stages on different physical cores. So we can assign the appropriate resources to that physical core, and it can be efficient enough because we have fragmented all the resources appropriately. The other way, the run to completion model has other advantages. This is that it is pretty much isolated, or can be isolated from all the other physical cores, and that's why they do not affect each other. So we can have all the resources like the caches and the memory assigned to one single physical core. There are also some tricks or techniques not even to use the hyperthread, because the hyperthread can trash the caches, things like that. So in some cases, not using the hyperthread and using only a run to completion model on a single physical core is really much efficient with the DPDK.
Okay, Andras Kovac, thank you very much indeed.
Thank you.